All we've done so far is prepare our virtual machine to support nested virtual machines. We now want to use our Ubuntu 2 machine as a hypervisor to host virtual machines. So for that, we need to install the libvirt and kvm hypervisor. There's quite a few tools here, so we do have a script you can run from our Git repository. Now, along with this, to be able to manage our virtual machines, we don't have a graphical environment. There is a Virt Manager graphical tool that we can use, but we're only using the command line environment. So what we're going to do is install the Cockpit web interface that allows us to manage our system through a graphical web browser, and the plugin for Cockpit machines allows us to manage our virtual machines. It's really, really useful and a great addition to this course. Now, to be able to work with our virtual machines, we can either use sudo and work as root, or we can add our Vagrant account, our user account, to the kvm group and the libvirt group. So it's your choice. Either run as sudo or add yourself through to the groups. But don't forget, if you do add yourself to the groups, you'll need to log out and log in again to pick up those group memberships. With this up and running, we can then go ahead and create our virtual machines. Using Cockpit, we can connect to the IP address of our system and port 9090. Now, be aware this is only going to be a self-signed certificate, so you will get warnings about that. You can accept those warnings and then navigate through to the virtual machines interface inside of our system and install from a URL. We'll start you through this in the labs, but be aware that it's not quick installing the virtual machines. We'll see later we can use virtual machine management with Vagrant to get up and running a little bit more quickly. But this is a good way to get us started. So come on, let's move out to our command line for our second demonstration. Working on Ubuntu 2, we can install the hypervisor, install Cockpit, and then from our host, using a browser on our host, we can connect to Cockpit on our Ubuntu 2 system, and we can then go through and create our virtual machine. Bear in mind that if we do allow it to run through the complete installation, it's not particularly quick, so allow an hour or so if you want to run through the complete install. But as I say, we will see managing our virtual machines later through Vagrant. Look at this. Ubuntu 2 welcomes us with open arms. But remember, we must begin by installing our hypervisor so we can actually manage virtual machines inside of our Ubuntu 2 system. Now, for this, we have got a few packages that we need to put on. So for ease, I've added to the repository just the list of the packages inside of a script. So if I look in LFCS, our Git repository, VMS is the course we're working with, and then we've got the install.sh file. And we can see there the packages that we are adding in. So bridge utils, libvirt, clients, the libvirt daemon, QEMU kvm, and the web interface Cockpit and Cockpit machines, allowing us to manage the virtual machines. The echo statement just reminds that we need to add our user account to the libvirt and kvm groups. We can go through and execute this with bash and then the path through to the script, which we get back to, remember, with escape and dot. And we can see then all of the packages installing for us, and also then just how easy we can make life for ourselves by providing these little scripts so we don't have to worry about the package names to install. So this can then run through and do all of the hard work for us. Now, I know we could have added to the scripts the add user statements to add our user account through to the group, but we've just got this little echo statement. So we do need to make sure that this is done. I haven't put it in the script because it's worthwhile just doing yourself and isn't that difficult. We can check the ID at the moment. I don't belong to any additional groups. And we can use sudo and add user. Now, in Debian distributions, this is a Perl script that can be used to create user accounts, but also quite conveniently, we can add users to groups. I can use my user account name Vagrant and then the kvm group, but we could also use $user. Even though I'm using sudo, $user variable is still maintained as our original user. and we want to add them to the KVM group and the libvirt group. So from a scripting point of view, I'm more likely to use $user rather than hard coding the user account name in. Now, when I check the ID, you might think, well, actually, nothing has changed. But use ID and then Vagrant, checking in the back end, and we can see the back end is okay. I just need to make sure that I log out and log back in again to pick up those group memberships. So don't get caught out on that in the exam, thinking, well, why isn't it working? Just try logging out and logging in again. Now, when we run the ID command, you can see I'm in the correct groups. We could also use sudo to manage it, so we don't have to add ourselves to the groups. Installing Cockpit would mean that we are now listening, as we see, on port 9090. So we can then connect through to this with our browser. Now, when we do point our browser through to it, the browser is going to complain about the self-signed certificate. So going through to the IP address 192.168.56.102 and 9090, if you're using the same IP addresses that I'm using, but we can then go into advanced and accept the risk and continue. We can put in our Vagrant user account name, and the password is also lowercase Vagrant. And then we can log into our web interface. Now, the Cockpit web interface is really useful. It's often installed by default on Red Hat machines, but it's also available to us on other systems if we install it, such as our Ubuntu system here. Moving down to virtual machines, we can then go through and create a new virtual machine. We can go through and specify to do a network URL install, and we can paste the URL in either from the slide, but we also have it in our repo directory. So the install_URL file has the URL to install from. I'm just pasting it in here. We can move down to our operating system and choose to install U for Ubuntu and 2004. I'm going to change the amount of memory just to 1 gig. And we can run an unattended install, so we don't have to worry about answering our questions. It is going to take a little while. These are not quick running through the installs. We need to put in our root password. We can use a generated one, which we will never remember, or we can go through and type one in and then create. Once we're ready with this, it's going to fire up our virtual machine. We see the virtual BIOS starting up, and then the installation is going to start, and we can then allow this to continue to run. As we go through, we can see the different screens that are coming up. As I say, it's going to take a little while. So whilst this is running, I'm going to move back to my command line. And from this, we can look at the virsh command, part of our libvirt tools. And if I run virsh and list with a T, we can see then that my Ubuntu One system is up and running. So we can see that we can start managing our virtual machines from the command line. I can do virsh list and -- all, and this would show me not just the running virtual machines, but any virtual machine that was stopped. I'm going to leave this running for a little while, and then we can come back to my virtual machine that we're installing later. If you don't allow it to complete, it doesn't matter, because we'll be looking at other virtual machines that we can get via Vagrant. Now, once the virtual machine has installed, we can shut it down. When we look at our overview, we can see the information about the virtual machine. As far as our usage is concerned, the disk space, the network interfaces, and of course, this is where we were with the console. Now, we can run it from here, but we can also go back to our console, and we can go through. Now, from our command line, if I go through and use virsh and list, of course, it's not running, so I don't see it, but I can then choose -- all, And we can see then it's shut off. To start it, I can use versh start and U1 so we can then start it. To shut it down, it's a little bit weird, but it's destroy. So destroy U1. So the domain is still there, it's just not running. And again, if I go back and list, we're able to see that it's there, but in the shut off state. Now we can clear the screen and move back to the top. If I truly want to get rid of the virtual machine because we want to look at a quicker way of managing our virtual machines, I can go through and use our versh undefine and U1. So now that's taken U1 out of our system, so we don't have the virtual machine anymore. And I say we're going to look now at managing our virtual machines using Vagrant and libvirt.